Hello, and welcome to the NextDent by 3D Systems open webinar, 3D Sprint Basic and Advanced Functions. We at NextDent and 3D Systems hope that everyone is staying safe and in good health during these challenging times. We also believe that we should use this time as productive as possible, both internally in our company as well as towards you, the users of our technology, products, and materials. We are planning a series of webinars in the coming weeks to offer you as much as education and insights into our products as possible. And some of them will be conducted additionally in Spanish, French, and Mandarin. We kick the series off today with a session on 3D Sprint, our nesting software from 3D Systems. As many of you already know, this software is of course much more powerful than just nesting, and we will address all these functions that 3D Sprints offer that will add value in your daily dental workflows. Your presenter today is Menno Pot. Menno lives in the Netherlands and is a dental technician, but also a certified clinical denture technician. He started working for NextDent in 2013 and currently holds the position Senior Application Engineer Dental. During the webinar, I encourage you to use the Q&A chat function if you have any questions. We will try to address these questions at the end of the webinar. So, without further ado, here is Menno Pot.
So, good morning, everybody. I already saw that there were quite a few attendees, so that's really lovely. Yes, like Stein said during his lovely introduction, we're going to talk about the 3D Sprint software and the 3D Sprint software in relation to the NextDent 5100, because the 3D Sprint software is software, nesting and slicing software, that is used for a large number of printers within the 3D Systems portfolio. We will start with the basics and then gradually take it up a step, and hopefully you will learn something today. And like Stein said, please make use of the Q&A. So if there's a question or did I forget something that you really want to know, then ask, and hopefully we'll be able to answer you at the end of this webinar. So let's start. When we are starting with nesting and slicing, we first have to go into the left-hand corner and select the correct printer. Now, this is for today, of course, the NextDent 5100, but you can see here the different types of printers that this software is also belonging to. When you select something in 3D Sprint, it becomes blue. And after you selected the printer, you can now continue to the different materials, the different applications that we have in our NextDent portfolio. The first thing I want to show you is how to orient, nest, and some other things you can do with our software when it comes to the models. Models are still one of the main applications used for 3D printing. When you select the model, you click on Next, or you can go here and click the tab. I prefer clicking Next, but that's up to you, of course. And here you see the three different colors currently running on our machine. For today, I will select peach, and we continue. There is one print mode, 50 micron. That means that we are going to print this object on 50 micron layers. And we continue by clicking next to the build style. We have three different build styles: orthodontic, optimized for fast printing of orthodontic models; the prosthodontic on the right, optimized for high accuracy and detail; and we added one, I think about a month ago, and this is the premium build style, which is optimized for higher detail, and also it supports solid horseshoe models. For the first thing we are going to show you on this webinar, I'm going to select orthodontic, and once we have selected everything, we click the set button, and now on the right lower corner you can see that we have selected the printer, in this case a virtual one, because due to Corona I'm also not at the office. We selected the material, NextDent Model 2, 50 micron build layers, the color is peach, and the orthodontic build style. Next thing we have to do is we have to, of course, import a file. So you click with your left mouse button on the file, go to import, and then folder that is on your computer will open. I made a special one for the webinar today. And let me see, I will start with the big model, open it, and there we have it. Now you can immediately see that there's something wrong with this model. We can see this because of the red markings around the model. That could mean there's something wrong with the model, but in this case it's simply because the model is not yet placed on the virtual platform of the printer. Now there are several options to get this model in the right position. Personally, I would like to first use the auto place function. You select the model, you click on set, and you see immediately the model is placed in the middle of the platform. And you also see that now the markings on the models have become blue. Blue on our nesting and slicing software 3D Sprint means okay. But this is not the correct orientation to print this model. And there are several things also that we want to change here, but I'm going to start first with more orientation of the part. We have several options, like I showed you before, the auto place. Another function is the orient option, and we will have the transform option. First, I would like to show you the orient. Select, go to manual, and now you have the option to set the base of your choice. By selecting the base, you can see the blue dot here. I select the base, and that means that this is now the base of the model. So this is the orientation we are selecting. One click and you immediately see that this model is now orientated in the selection of our choice. The movement of the entire platform is done by holding the right mouse. And when I want to move the entire platform, I just select Shift, right mouse, and then I'm able to move the entire platform. Now, we also see that this model is a solid model. It's a closed solid model. On the NextDent 15100, we strongly advise you to print with hollow models. Now, we selected the orthodontic build style. And let's say that we want to, after we printed this model, we want to vacuum cast something on this, like a retainer or an aligner. Then we do not need a lot of this mass that is here. So let me show you some tips and tricks on how to change this. We have the split option. Again, select, the window will open and you have two options, plane and line. First, I will select line, and then just by clicking with my left mouse button, I can create a line just by clicking every time. On the last one, there's the double click. I click on the next button here. And then this model is split in two. You can now select this part of the model, and by just clicking delete or backspace, this part of the model now is gone. But I also want to get rid of this middle section because I don't need it for this particular case. Therefore, again, I select split, take my line, left mouse button, just create the line that you want. Double click on the last one. Oh, sorry, double click. Yes, here we are. And then continue with next. Some calculations are taking place now, of course. And you see that now we have this option. We click done, and here you have it, two different models, split models. You can also see this here. It became from one model into two. Just by, again, selecting is blue. We click delete, and here we have more like a horseshoe-like orthodontic model. But the model is still solid. And like we advise you, print hollow models on the NextDent 5100. Of course, these hollow models can be created on the CAD software, which we advise you. But for whatever reason, if you receive from a customer, for example, a solid model, we have the option to hollow this. Select the model and go to holes. Then we have the distance. We have a minimum wall thickness of 1.5. For this particular model, I will select 2 millimeters and then I click hollow. Again, the computer will calculate and you see now that the model is hollow. If you want to make sure that the model is hollow, there's also the option with the view button here on the right to select transparent, and then you can see that this part is in fact hollow on the inside. When we open this window, we also have other opportunities. Here we have the opportunity to zoom. This can also be done by using the mouse wheel, which is my preference. But if you are used to using these kind of buttons, there's the option as well. We also have these buttons, which can, of course, we know this from similar software packages, you can select the different orientations. Now, let me see. For this one, I would like to have the front. And then again, I can go to the split option, but now I'm not using the line, I'm using the plane. And I'm going to drag this a little bit. And if you see here, this is the bottom of the model, and this is where I split. And by now splitting the model, we do not need the connectors. So we deselect the connectors. We are done. And again, we have now 2 different files. Again, I delete it and I will get rid of the transparency. And you see now that we have created a hollow model, which is ready to print. Now, we could go continue and support the model, but it's also very convenient if this model, if you print several models a day, that we have some kind of engraving. This is also possible in this software. You select the model, you go to prepare, and then you see that we have a different window and the different opportunities. For this one, I will select, like mentioned, the engrave. I will orientate my part. I will select the text. This could be, of course, a patient number or a patient name, whatever you want. Then by clicking the left mouse button here on the corner, you can make the window smaller. And then you can fit it in, maybe a little bit more to the right. And then when you feel that this is the right location, you click engrave. You have several options, inward, outward. For this, I click inward. And for me, the settings here, the offset distance can also be changed. I would like to have it on 0.5 millimeters. Then I click apply, close the window, and you can see now that there's a nice engraving on this model. Select the model, it becomes blue again, and we go back to print. Because we took a part from the bottom, we now want to make sure that the model is as close to the platform as possible. This is saving you print time, and this can be done by the other option when it comes to orientation. We had the orient button, we had auto placement, but we also have the transform button. And by clicking on move and rotate, we can now orientate the part to every direction that we feel like. I just want to drag it down a little bit. So here we have the cross, left mouse button, and bring it down to the platform. Close this. And then a very nice and important feature is the smart support. A lot of software packages, they create supports, and the supports are roughly all the same. In 3D Sprint, for each and every application, the engineers of 3D systems created special supports. So it's also important that you select the right supports. Remember, we selected the orthodontic build style. So now for the supports, we also would like to select the orthodontic support style. You can see there's also a prosthodontic and we have the premium, but for now, we select the orthodontic build style. We create the supports. The computer is calculating now how to place the supports and how many supports we need. And here we have it, a lot of supports placed under this model. And now by using the 3D Sprint software, we went from a rather large solid model into a more manageable horseshoe model, which is now hollow and ready to print on our machine. Another nice option here is the estimate button, because how long will it take to print this actual model? Now you can see that this is an orthodontic model, quite high still, but it will only take 16 minutes to print this model. Now we still have room on the platform, so if you have a second model, you can put that aside this model. I will show you later on that this is also very easy to do. And then the printing time will still be 16 minutes. Why? Because we are printing in layers and the printing time is determined by the highest part. So let's say if we have a second model which is somewhat lower than this model, the total print time will still be 16 minutes. Another thing we have here is the material estimation. We see that the NextDent model 2.0 shade peach, we have to use roughly 32, or let's say round it up a little bit, 33 grams. Now that is quite a lot, but this is an estimate, a rough estimate, I would say a high estimate, because you do not want to have too less of material in your resin tray. So for this particular model, we know that if you fill the resin tray up to the minimum fill level, which equals 150 milliliters, you will have more than enough. Actually, for all the applications that you can print with the NextDent 5100, and you use the entire platform, the minimum fill level for the resin tray on the machine will be more than enough. Now, this is one model I would like to show you. Then we have another thing that I would like to show to you. For this, I will take a new file, just open, and you will immediately see that this is no ordinary file. There's really a lot of things wrong with this file. This is actually an intraoral scan of a model. And at this moment, this is not printable. You can see this, it's red. And red could also mean that it is not yet in the right position. But if we select it and we drag it towards the platform, you can see that this is actually not the case. Try to fit it in there. And you can see once it's inside the platform, it still shows that it is not really a good model. If you're orientating, you can see that we have several colors. We have white, we have green, and we have blue. And the colors, they are, let's say, aligned. Let me show you if I can make it a little bit larger. No, this remains the same size, but you can see that the Z, Y, and X axis are the same colors as the orientation on this box. So if you want to move something on the Y axis, you select the green one and you can just rotate it like that. And when it becomes green, you select the left mouse and then you can move it around. Now, back to the model. The model is really bad, I would say. And for this, again, we go to the Prepare tab, select the model, go to Prepare, and then we have here on the left-hand side, we have the Fix option. So we are able to fix this model and to make it into something printable. Select Fix, and you see that there is a few open boundaries and there are some self-intersections, and the software is able to fix this. Now, this will take a little bit of calculation. It's also depending on file size, computer strength, etc. But after the calculation, you will see that the part is turning blue. That means for us that the part is printable. We'll just give it another second or two. And hopefully the software will prove me right. And there you have it. You still see that there are some self-intersections that could be fixed, but for us at this moment, this is enough. But we still have a hole here. It's a rather large model and we're still printing in the orthodontic print mode. So again, we can change this by making it into a nicer model. So again, I have selected the split option and the line. Again, some calculations. Of course, this is known when you are working in some kind of CAD software or nesting software. Sometimes you have to wait a little bit. Click on Done. Select the part you want to remove. And we repeat this again. We want to make it into a manageable model. Calculations. Done. And you see that if we have selected this, this is now turned into something that actually is printable. But again, we still have the closed model. And also in prepare, we have the option to hollow a model. This hollow, you select, again, I'm going for 2, select the model, set. And then the model is hollow on the inside. Now we can, of course, cut off a part. We can go here, select the plane. Now you can see this is somewhat more challenging because the orientation of this model is different than the one we had before. So you might have to adjust this line before you actually do the actual splitting. Again, we select this option. We discard of the connectors. We do not need it. The connectors are there if you want to have 2 parts and later on you want to reassemble it, like let's say with the Lego system. But for this option, this is maybe used in industrial, but for us in dental, this is not something that we would use. We take off the bottom part and here we go. Now we have something that we can print. You might have seen that the part by now is turning yellow. So again, we have to go back because of the things that we've done. The part is not really printable yet, but you can see that now it's turned blue. We can go back to the printing. We could add supports, etc. Of course, after orientating the part, supporting it. And then we could print. So you can see that we have now used several options here. Of course, we have the printer with the selection of the material. We have the file. Another thing I would like to point out with this here is that, of course, the import button is the most important one, then most frequently used. If you close, the job will close, of course. If you open, you are browsing in your files. But here are 2 other options which are sometimes very useful. If for whatever reason you have a print fail or a question on something, then it's very easy to save as. What this does, this function saves the file as a 3D sprint file. And let's say, for example, our support team would like to duplicate what you have printed on your printer. You can save this file, you can send it to support, and then we can duplicate the exact model, the exact orientation, exact support cell, etc., etc., and hopefully find out what went wrong and how to solve it. So the save as function is very nice. We also have some other features here. Scaling. Scaling, I would not advise to open this. Like I mentioned before, it's the software is used on many printers within the 3D Systems portfolio, and this might be useful when working in industrial, but we do not like to scale our parts because then we lose all sense of direction when it comes to orientation, quality, etc. Quality check, you can check your part quality, but actually the blue line is an indicator that the quality of this part is good. If it's orange or it's red, then we should fix it. A feature that might come in handy is the measurement feature. And if we go to the bottom of this part, you can just go here. With control, I'm selecting now here a small dot. And by clicking on your left mouse button, then you select the placement of the ball, the second ball is placed, and you can see I selected 2 millimeters, and you can see that this is roughly 2 millimeters. That's of course that because of the placement of these balls. Could be very interesting to have this knowledge. Also maybe something that support will ask. Sometimes we get some questions and then we look at the model, we say yes, but we advise 1.5 minimum thickness, and this model is thinner than that. Please make it thicker, and then the problem might be solved. So there's also the option of measuring an angle or the radius of a circle, of course. The orient button we already saw. Auto placement is something that we can use. This is something that we have not seen, and this is very, very simple actually. You just select copy. If you want to have 2 models, one model for working, one model to send to the dentist, this is absolutely possible. Here you have it. Now we created a duplicate model. Transform. Important here that we have several options. I'll try to explain a little bit more. We have the move, where we can select and we can make use of the box and of course of our left mouse button. But we also have the rotate function, and then you can rotate on certain degrees. For us, this, when the part is oriented flat to the platform, this for us is 0 degrees. Let me see, let me change this a little bit. So for us, this would be 0 degrees. And if you want to change something, because for each and every application we have an orientation that we think is the best for print quality and part quality overall, you can just select a number and then the part will orient in this direction. Remember, X, Y, and Z matching the colors. So you might have to fiddle around with this somewhat, but if we say that this part should be printed in 15 degrees angle, this is where you can do this. Also, something I would like to say, if you have made a small mistake, it's always possible to go back. So by selecting this arrow, you go back. If you want to go further, so you want to go one step further in the software to your last step, let's say, then this is possible. You see, this is now the last step, so it's no longer selectable. Here we can see that it is. We have the mirror, not used for dentistry, because what will happen is actually you will mirror the part, but if you want a second part, please use the copy. Split, we have looked at that already. We have the plane, we have the line. The holes to hollow the part. You can also use this to create holes if needed. And this is also a nice feature, the generate geometry. Here we have the possibility to generate a geometry, a box or a circle. By typing in the numbers, you can see that the part will already change form and shape. And by setting it, you will now have created a geometry part. Not always used for dental, but this opens up possibilities. For instance, if you want to create a bar between the model, then this is an option to do so. In combination with combine and separate, you can combine this part to the actual model if you feel the need. Okay, a little bit more about supports. You create the supports. It takes a little bit of time. I am getting rid of the. We have created now the supports, and there's possibilities to change the supports if this is needed. Now we have smart support. So I already explained this is support for each and every application and each and every build style, each and every material. We have slightly different supports. If we are printing crowns and bridges, we have very thin support tips, because then the support scarring is kept to a minimum. If we are printing models, they might be slightly bigger because the model is bigger by itself. It's more volume, therefore we need somewhat bigger supports. But what I'm trying to say is that smart support works. Please do not change support settings, And if you want to modify, adding a support is never a problem. You can just do that by here, modify, add, and with the left mouse button, you can add some supports. This is never a problem. Getting rid of supports is always tricky. You can do by just clicking on it in the erase function, but this is tricky because you need support at certain places. Supports are there for a reason. So I'd rather have you move supports rather than erase supports. And again, adding is no problem. If you have changed something here in the supports, please make sure to update the supports, and then everything you changed is now updated. And again, the print, you can send the model and supports to the printer. Now I selected the virtual printer, so I cannot send it to the printer directly, but normally you will send it to the printer and this will open this tab, the queue. Now these are the printers that we use in the R&D department and the applications department. They are not connected at this moment as I work from home, but normally you will see all the jobs printed and to be printed in this queue. So you can also control here by these faded out buttons at this moment the order of printing. So if you have selected something to print, but for whatever reason you need to change the order because the dentist made a mistake and the patient is not coming tomorrow but today, you can do this here. You can print that particular model faster or first. Back to printing. I will get rid of this and I will continue with yet another file. For this, I will select the surgical guide. And again, here we see it's red simply because it's not on the platform. By clicking auto place, it becomes blue, but also here, this is not the orientation that we would like to have for this particular application. Make use of orient, select manual, click it, and now you can see that the hole is, let's say, perpendicular to the platform. For whatever reason you want more than one, you can just select it, click set, and you see that automatically it will place 2 extra surgical guides on the platform. Once more to support. Why am I showing you the support? Because now you can see there's something wrong. I selected a new part, but I didn't select the right build style, etc., etc. So keep in mind that if you select a new part, you always have to select the right printer. But like I was mentioning, if you select a surgical guide, make sure you also select the correct build style, etc. So we're back here, click on surgical guide. There's only one color available for this particular material application. One layer thickness that we can print in. We have the standard build style and we set the build style. Now I had the file already imported, but that was on the other software. So I will redo this. And then I will quickly place it in the right orientation. And this will actually show you that normally this is quite fast. So the main reason why I have shown you this is that we have a new support style. The nice thing about 3D Sprint is not only that it is, of course, a brilliant nesting and slicing software, but it is also a 3D system software. So the application team is in close contact to the engineers of the 3D Sprint software. And what this allows us to do is we listen to the market. For instance, here we had the surgical guide. We had a support style that was creating supports which worked, but they were quite thick. And sometimes small pieces broke off from the printed part. We went back to the software guys and also the printing engineers and said, look, is there something we can change? And they said, yes, we can look into this. and then they made a new support style with very, very thin support tips that now if you print the part after printing, these supports are very easy to remove, almost no support scarring. And this means that after printing, you remove the support, you wash and post-cure the part, and then you can directly send it out to the doctor. Another thing I would like to show you here is that sometimes the supports are placed in an area where you do not really want it. You can see here that now the software generated supports on the inside of this surgical guide sleeve. And of course, this is not where we want it. The reason why this happens is that the support, the smart support, calculates where to place the support just from a 3D printing point of view. So no, not so much from a dental point of view. So this is something that you have to be aware of, especially with surgical guides. That's why I'm showing you this. So you have to get rid of these supports inside. Now remember, erasing is not the best option. So what we are erasing here, we are going to add along the side here. So first I'm going to select, and that's also an option that we have. It's a box where we can get rid of some supports at the same time. Let me see here where there are more here. Is there anything else we would like to remove? No. And then just where nobody really is bothered by these supports, we can then add several supports. This one also not really fond of. And again, if we click update supports, you will now have all the supports in place, but no longer in an area where we do not need it. Next application, we are going back to the model, and I would like to show you something because if, for instance, you are printing this model, which is a really perfectly nice model, but it has a very steep palette. And during printing, this steep palette sometimes causes an issue. I would like to show you why this is happening. We can open the view. I will drag my model a little bit to the left here. And if this is a small screen of my laptop, but normally if you have a full-size screen, you will immediately see this option. You have the clipping option. And by selecting this, Z, you can now walk through the part, layer by layer, I would say. And you can see that this particular part here, it creates a cup. And this cup during printing could work actually as a vacuum cup. And it is a closed volume, also referred to as closed volume. What will happen during printing, this is a kind of a vacuum cup, and this creates forces, and this might cause slight delamination on the part. And what will happen that you will print the part and the inside of the palette is really rough, really ugly print lines. Now there is a small trick that you can use. You can, I will just get rid of this. You can go to transform, rotate the part. Snapping is 10 degrees. So if I take the part and I tick 2 times, that means that I've selected now 20 degrees. You can also type it in. Then we go back to this. And if we now look at the part, this void, this cup is no longer created. I will tilt it a little bit more so you can see. If we walk through the part now, layer by layer, this is perfectly fine to print. And now you will have a model which is perfectly printed all the way through. Okay. That was the orientation. You can also, of course, use the other axis, but here for what we call the cupping problem, this is a nice feature to look at it, look at the model, and by orientating it slightly differently, you can overcome this small issue. Very popular today is actually also printing dentures. So I would like to show you the orientation that we at the moment feel is the best. Because we have two critical areas. We have, of course, the tooth fitting surface, and we have, of course, the surface that fits to the gums. So the orientation that we would like to use is the orientation that I'm going to show you at this moment. I will rotate it a little bit like so. And then you can either use this button, or you can select the amount of degrees. And here you have the orientation of our choice. So we print these upper dentures with what we in Holland call the A line or A zone, the end of the denture, to the platform in a 60-degree angle. Again, if you are printing something else, you must select also the different build styles, etc. Now, please don't run into problems again. Yeah, luckily for us, it's working. So again, you have to select the material of your choice. At this moment, I like to use the opaque pink. It's just a matter of color. I like this color personally. And we have some build styles which are for testing, but we use the standard build style. We go to support. We create the general supports, and then the software is creating some supports. Now you can see that there is a minimum of supports. Again, if you feel the need of more supports, and this is something that I just have a gut feeling that you can add more supports here to make the part more robust. Update the supports, and here you have it. Okay, normally now it would be time for Q&A, but I understand that there at the moment are no questions. Is this correct?
Yes, thank you, Menno. Well, there are no questions in the Q&A of this webinar. Probably because there are some technical problems with it. I received one question over the Facebook post, and that has to do with the position and orientation of the models when we import them. They are in the 0 point or not inside the platform. Maybe you can comment on that a little bit. Why is that, and is this something that will change in the future?
Good question. Let me take the model that we've used. That the models are not inside the platform, that is actually almost always the case. And we are going to hopefully change this. And in order to do so, we need some information in the STL files. So this is why we work with the CAD software companies, the dental design companies, because then they can say to us, look, this model should be orientated, or we should say to them, excuse me, that this is the orientation that we want. So if you can give this information to your STL file so that this is the bottom of the part, then at least the part will always come in like so. And the number of models from different software companies already have this. Then having this inside of the platform is slightly more challenging because we are working on this. And for instance, with the new feature that we are releasing, hopefully by the end of this month, coronavirus also has an effect on our schedule, as of course, but it's still planned for the end of the month. We will have the auto stacking, and this software makes it possible to orient the models and also place them inside of the platform. And you can imagine that this is also possible for the normal models. So some of the models already come in oriented in the correct way, some of them don't, and it's actually because a little lack of information on that particular STL file.
Okay, thank you very much, Menno. A second question that came in is the software generates supports automatically, so there is some logic and knowledge behind that. When you start moving these supports around, are we still safe? Are we still sure that it's printable? Can we see this somewhere?
That's a good question again. The main thing that if you use smart support is that you that you trust smart support. So I would leave smart support alone, not change it, only if there is a support in a critical area like I just shown you with the surgical guide. And unfortunately, at the moment, there is no possible way to see within 3D Sprint that the part is still printable, yes or no. But we work quite simply with the guidelines that if you follow smart support, adding support is no problem. Replacing support is doable, but removing supports should be kept to a minimum. So only remove supports if they are really in a place where it is not beneficial or against, let's say, our dental design rules.
Very good, very good. Maybe it is also a good idea to check the printability manually yourself in the slice view or in the cut view. Menno, you want to elaborate a little bit on that in the view function, the Z cut?
Yeah, you're referring to this. And what is it actually you want to?
Well, with this, you can first of all take a look if your supports are on the lowest points, that you don't have any free starting zones, and maybe also a little bit notice about the cups.
Yes. Okay. Then I will have to change models because this is the solid one to explain it a little bit more in detail. So I will take, first of all, this can be switched off. I will have the file, which is the split one. So what Restein is referring to is that we had the cupping, let's say, but if you want to look at where models should be placed, there is the down-facing option. And let us see the angulation. Now, all the red areas are down-facing surfaces. This means that they would require some supports. Now, this is a very high number. I will change this because then I think it will be easier to see. So now I changed this number a little bit. So you can see the dark red areas absolutely need supporting. The yellows, not so much, maybe a support. So this could be a helpful tool if you have deleted supports and to show you where to replace the supports. Now, remember these red areas. I will try to show that the software actually works. Therefore, I have to, of course, change from denture material to the correct model material. Orthodontic, yes. And if we click on support now, hopefully we'll see that the edges that are really red are supported. It takes a second. And you can see that is actually exactly where the supports are placed. So proving us that the majority of the supports, a lot of supports are placed in the red areas. In the somewhat more yellow-orange areas, there are some supports, but not so much. I can see this here more clearly. So the down-facing surface that we have here under the view window could help you if you have removed supports and if you want to replace supports where you should put them. But again, please trust smart support. It's a very nice tool. A lot of people have done a lot of work on this to make this functional. So I think it's one of the nice features that we have within the software, because actually you can go from selecting the material, importing a file, orientating it into the right direction, select smart support, and within a minute or two, you are ready to print.
That's great. That's awesome. I have currently two more questions, and they are related to this topic. One question is, when you go into your printer settings and you select a build style, for example, for models, you can choose between orthodontic, prosthodontic, and premium. But later, when you do the smart support, some very smart people have noticed that you there also can then choose between orthodontic, prosthodontic, and premium into different sizes. Will this override the build style is one of the questions. Of course, it will not, but you can explain that. And what is the difference there?
Yeah. Like it's a good question, and they paid attention when I showed this, so this is very good. Yes, if we click orthodontic build style, that means that there's also a orthodontic support style, and I will try to because the models differ a little bit, and therefore also the different supports. So if you change it, you can see that immediately you get a warning. Parameters have been modified. If you want to apply this modification, anchor points need to be regenerated. Do you want to regenerate anchor points, etc.? Let's say I want to do this. Then you can see that there's a calculation and that the supports will be totally different. So if you have an orthodontic model, but you select the prosthodontic support style, this will probably fail. You can see that the support tips and everything is really different. Also, the amount of supports is different. So that is why it is important, if you select orthodontic, that you also use the orthodontic build style. We also have the same build style for premium. And if you angulate the model a little bit and you are in premium, you select the angulated build style or support style, sorry, for this. Hope this answers your question. And like Stijn said, it will not overrule the build style. So it's not so that if you change this here, then the settings will be changed there. It's separated.
Yes, perfect. Thank you so much. Last question currently, unless in the last minute something else will come in, is also a very, very good question. If you ask me, is it better to, if you have one part, one model or one surgical guide or denture whatsoever, is it better to put it in the center of the build plate, or does it not matter where you place it for our printer?
Yeah, again, a logical question, because a lot of printers show a difference between the center and, let's say, the edges of the platform. I'm happy to say that this is not the case here. It's just convenient to place something in the middle, and also autoplace will place it central. But from a printing point of view, it doesn't matter if you orientate the part, let's see, from to this side. It will not do anything in regards to print quality. So
yes,
if you have several parts, it doesn't matter. They should all be the same accuracy after printing, of course.
That is great. Perfect. Still one more question, or I think it will be the last question. We take it back to dentures now. You showed the orientation of the denture base. Is that the recommended denture base orientation, and why is it?
Yeah, again, a good question. The denture base for the CE is not yet available. So that's why currently the application team is looking at what would be the best orientation for printing dentures. And let me see if I can take the denture. It's always easier to explain when you have the real thing at hand. And at this moment, we have found that the orientation that I just showed is and we're talking about microns, no mistaking there. If you would print it like this, I'm sure that you will also have a fitting surface, but you can also see, because we all still have the down-facing surface on, that in this orientation, there will be a lot of supports inside of the denture. So this is, of course, not what we want. Although the support tips are very thin, you would affect the fit of the denture. Now, if you would flip it, then you will have the same issue with the teeth pockets. So the supports will be in here, and that will make fitting of the teeth kind of challenging. So that's why we are already in an early stage looked at orientations that were more or less under an angle, let's say like this. But we have played around with different orientations, and we found that an orientation of 60 degrees gives you an overall better quality both from a tooth fitting surface and a inner surface, so the surface that actually touches the gum. A nice advantage also here is that if you place it like this, you can fit 4, maybe 5 dentures depending on the size in one platform, and make sure that everything is printed nice and accurate. Is this answering the question?
I believe so. Very good. Thank you for all the
great.
information. Now, one more thing that we would like to point out, there are some question marks here and there in the software. If I'm not mistaken, of course, they will get you to a help page from 3D Systems. Menno, maybe a short message on that?
We have 2 options here, very important. If you are a beginner, but also if you are more expert, then we have the question mark. Okay, so I selected the question mark and it will take you to the information about that specific option that you are in. So you will find the question mark on all the other functionalities. The reason why I went to Smart Support, because also here we have what we call must-watch best practices. And this is very nice, especially if you're new with an application. You can find all the different applications, dental application guide here, and we have instruction videos on each and every application. So everything I showed you is more or less here in this video as well to a specific application. So if you are new to the software, you're starting to print dentures or surgical guides or models, it doesn't really matter. You go to the best practices and there you can find a lot of useful information to help you begin to use 3D Sprint.
Awesome. We have very attentive attendees today. Somebody wants to go back to the view function, the view option, where you showed the red zones. So that's the down-facing surfaces. Can you show one more time where that is?
Yeah, so if you go to the view, you have several options, and we have the button here, which is down-facing.
Awesome. Awesome. Very good. And the very last question that I just got in, do we have any tips on printing vertical models? Not sure, this could go 2 directions. We can quickly show just an orthodontic model placing vertical, so you can fit a lot of models in the build platform. But of course, we also have stacked printing that we released in Chicago Midwinter Show in February, which will roll in automatically into the 3D Sprint update, probably end of this month. We will have another webinar planned next week, so keep an eye on social media and our website. The webpage that you started from right now will be uploaded with a schedule on more webinars, and one of these webinars will be the new functionality in the upcoming 3D Sprint, where we will handle stacked printing for orthodontic models, but also some new features in denture printing and so on. So that's going to be very exciting as well. Menno, maybe quickly go over this, what we currently do for orthodontic vertical printing.
Yes, so normally for a horseshoe model, now we don't have the horseshoe models because this is a different file at hand, but for horseshoe models at this point, it is perfectly fine to print them in this direction. Now a horseshoe model, of course, we saw this earlier, will not have the big base and it will be without the palette, otherwise it would not be a horseshoe model. But for orthodontic models, horseshoe models, you can print them like this in the current software. And yes, we are happy to announce that we will release an awesome feature free of charge, by the way, in the latest upcoming update that's called Stacked. And what will happen is that you will load in all the different orthodontic models. It doesn't matter if they're closed, if they are, let's say, hollow to a certain degree. It will make them all the same when it comes to the model thickness. It will create supports. It will stack them. I will try to show here, but that will be done automatically by the software until the total Z-axis is used, and therefore within this new package, software package, when it comes to orthodontic models, you can print up to 25. As I've already seen our testers print 30 models in about 1.5 hours.
Yeah, the maximum so far, I believe, is 40 models. So
40 models already. Okay.
yeah, if they are small, the smaller they are, the more you can fit, of course. And yeah, the print time for a full volume of printing will be approximately 2 hours. So that's very exciting. We're looking forward to hand this over to the broader market. And by this, I think we can conclude this webinar. Thank you everybody for attending and the very good questions that we have gotten. Like I mentioned before, keep an eye on social media. Let me see to bring this up. Keep an eye on social media and the website so that you can make sure to attend the next webinars about the new coming features in 3D Sprint, but there will also be webinars more about the printing and finishing of dentures, for example, and other stuff coming. If you have any ideas about topics that you want to learn more about, let us know through our social media channels. We are here and we will generate the content and broadcast it to you live. So thank you very much. I wish you all stay safe and healthy and hope to see you all again soon live at one of the shows, exhibitions, as soon as we can travel and organize those again. Thank you. Bye. Thank you, Menno, also for the great presentation.
You're welcome, and thank you everybody for joining. Hope you learned something today.
All right. By this, we ended this broadcast. Bye.
Bye-bye.